Welcome back to the session. Today we are going to discuss about the dual nature of radiation. Question arises, what is the meaning of this statement, dual nature? Here by dual nature we mean radiation or the light energy is possessing two properties. That two property we have to discuss. So the radiation is expected to have particle nature and wave nature. These are the two natures that is expected of any radiation. Particle nature, when we say, the particle nature is exhibited by what is called photoelectric effect, and the wave nature was established by the Davison's-Germer experiment, where the scattering of the radiation was recorded. So wave nature and particle nature. So wave nature was established by Davison's experiment. Now this is exactly what. Our aim here to understand what is photoelectric effect. So question arises, what exactly is photoelectric effect? So if we see this photoelectric effect, what exactly is involved in photoelectric effect? Please understand, photo means light. Photo, it means light, right? Now, and electrical energy. So light energy is converted to electrical energy. This effect, this phenomena is photoelectric effect. So in photoelectric effect, what we observe is the light energy is converted into electrical energy. This phenomena is called photoelectric effect, and the current so obtained is known as photocurrent. Now let us try to understand how exactly are we are experimentally verifying photoelectric effect. Well students, the setup for studying the photoelectric effect, let us see, we have one plate like this. Now, what we can say is, or we can say something like this, and we have one more plate like this. This is an evacuated tube, and this is some electron rich oxide. See, there is no connection between the two. Now what I will do is, see, I have connected a lamp here. Now I have connected a cell just to maintain this plate positive with respect to this plate. Now this is coated with electron rich oxide. When light of characteristic wavelength is made incident on it, See, light of characteristic wavelength or frequency is made incident on it. Then what is observed is, from this surface electrons are emitted from the surface. See, from here electrons are emitted. The question arises, will every incident light have the capacity to emit such electrons? No. Why? Because every metal, every surface has a property that is known as work function. You need to understand these terms. Work function. What is work function? Work function is the minimum energy. It is the minimum energy required to liberate an electron from a surface. This is called work function. So it is a minimum energy required to liberate. Why? Because on every surface electrons will be held to the surface. They are not free. So if we supply energy to those electrons, then the energy of the electron increases, and thereby it is able to break away from those forces which are trying to bind it to the surface. That energy is known as work function. Now we can say work function is equal to h nu naught. This nu naught is called threshold frequency. What is threshold frequency? Threshold frequency is the minimum frequency which can provide the required minimum amount of energy to the electrons. So threshold frequency is the minimum frequency which can provide work function to a metal surface. Got it? That is called threshold frequency, and that is also work function. Now what we have is, these are the two terms which are essentially to be understood. Now question arises, what happens if to a surface less than the threshold frequency or less than the work function, threshold frequency is incident? If the incident light is not able to provide work function, any amount of photon incident on it, any degree of intensity of such a light will not cause emission of electron from the surface. So the minimum requirement out here is this frequency should be greater than the threshold frequency. Then at any intensity of the incident light, emission of photoelectrons will definitely occur. But remember, if the incident light has a frequency which is less than the threshold frequency, even if we make the incident light highly intense, it is of no use. No emission of electron can ever happen. Now, what we have understood, the incident light should have a frequency greater than the threshold frequency. This is what we can say, correct. Now see, suppose that, let us assume one surface has a threshold, it requires 10 joules electron volts of energy. Now the incident light is able to provide 8 electron volt. Will there be emission? Definitely there will be no emission. Now please pay attention. Suppose that the incident light is capable of providing exactly 10 electron volts of energy. Will there be photo emission? So here the question we have to understand very clearly, will there be photo emission? Now it is not asked will there be photo current. The question is, will there be photo emission? Yes, definitely there will be photo emission, but that emitted electron will not be able to constitute photocurrent because it doesn't possess any energy which can be converted into kinetic energy and it can start moving. So photo emission will happen? Yes. Will it constitute photocurrent? No. Now once it is emitted from the surface, after some time it will be again pulled back to the surface. That is why what we say is the incident frequency should always be greater than threshold frequency. What you can write here is frequency is greater than threshold frequency. You can mention like this. In that case, definitely whatever is the energy required to break away from the surface will be taken and the remaining energy will be available with the electron. And that photoelectron will be made to move with the remaining energy and that will get converted to photocurrent. Yes, but before that let us understand this. So light of frequency nu and possessing energy of h nu is incident on the metal surface. This surface is coated with electron rich oxides like barium oxide, strontium oxide. Why? Because lot of electrons will be available in such oxides, so number of electrons can be emitted. Now see, this plate I have maintained at positive terminal, so this will act as accelerating potential. Whatever potential you are providing here will behave as accelerating potential. It will behave as accelerating potential. Why? Because this being positive and the electron which is liberated here, electron negative, it will be attracted strongly towards the plate and the path of the electron is complete, the lamp will glow. This is exactly, see, although there is no connection between the two, still we find that the lamp is glowing, which means that somehow the electron which is emitted from the surface, they are able to complete the circuit, and that is exactly how we are observing electric current in that particular circuit. Now, how to estimate? So this is exactly what is the theory behind photoelectric effect. So the compulsory condition is what? When electron or is receiving energy which is sufficient such that it can break away from the surface, then that electron will be emitted from the surface and it will be attracted toward the plate. When it is attracted toward the plate, they will constitute what is called a electric current. Now, let us see the energy and all those things. Now, the photoelectrons now, students, see, the electrons which are possessing energy, how much is the energy possessed by it? H nu, out of which this is the energy which is lost as a result of work function. Now, whatever is the energy left, this is the energy left. This energy left is providing the kinetic energy. This is h nu minus work function. This kinetic energy we say at half mv square. This is what you call as Einstein's photoelectric equation. See, here Einstein has justified that photoelectric effect is a confirmatory proof for the particle nature of radiation. How can we say that this is particle nature? How is it justified? So in order to find out that, see here, half mv square is the kinetic energy, and kinetic energy is of what? Kinetic energy is always of a particle which has a mass m. So definitely this is an equation for the particle. So numerically also we can establish, but otherwise what is the reason for it? Now, the reason goes this way. Incident light radiation falls on the surface. Surface is electron rich. Now the electrons which are present on the surface, they will absorb energy from the incident radiation, and that is the reason why they are able to break away from the surface and come out. So if the electrons are coming out of the surface, this means that they are able to gain energy from the incident radiation. Now if they are able to gain energy from the incident radiation means what? Means that electron we know is a particle, it has some mass. And how can a particle gain energy? Definitely it cannot gain energy from wave. Can we say that I will collide with wind? Is it possible? It is not. Wind, wave, and we are having some mass, so particle behavior we are exhibiting. So how can you collide with wind? Collision happens between two bodies of same kind. Wind cannot collide with another wind. They will mix. But two vehicles will collide, they will not mix, because the two vehicles are possessing mass. So they will collide. So collision is the virtue, is the property of particles, which means that if the electrons are gaining energy here, then definitely they are gaining energy from another particle. So this what is incident from where the electron is gaining energy should also behave as a particle. That is exactly how it was justified that photoelectric effect is a compulsory proof for what is called as particle nature of radiation, and this was the proof given by Einstein in support of that particle nature. And this is what he has given the mathematical equation how to justify how much is the energy. Now from this many equations can be extracted. You can simplify this. You can write like this: half m v square, you can write like this, hc by lambda, or you can write work function as h nu naught. So this can also be written as hc by lambda minus hc by lambda naught. This way also you can write. So different formats of the same equation. Now this was about the accelerating potential. What if we reverse this polarity? What will happen if we reverse this polarity? If we reverse this polarity, then what we find is, let us argue what happens when we reverse this polarity. So if I reverse this polarity, what happens is you give here negative and here positive. This is not accelerating potential. See, negative. So this is what? Retarding potential. This is retarding potential. So what happens when we apply like this? In this situation, the electron whichever is coming will be strongly repelled back to the surface, and there will be a magnitude of the retarding potential at which the lamp will not at all glow. As we increase the retarding potential, the lamp becomes dimmer and dimmer, and there will be a stage where the lamp will not glow only. When that means no electron is able to reach the other end, so the circuit is completely broken, or we can say that is known as the stopping potential. So the next term that you will come across is known as stopping potential. V naught. What is stopping potential? The name only suggests it is the reverse potential, compulsorily reverse potential. It is the reverse potential at which the photoelectric emission completely stops. Stopping. It is the reverse potential at which the photoelectric emission completely stops. So what can we say? What is the inference we draw about the nature of the stopping potential? Stopping potential is the measure of the kinetic energy of the fastest photoelectron. That is what we can say. Second thing, stopping potential can also be said as the measure of the maximum kinetic energy of the emitted photoelectron. So we can say half m, this is exactly how the relationship between the maximum kinetic energy and the stopping potential can be established. So these equations once again will give us some insight. So how exactly are we going to use these equations? So see here, Q into V naught can also be set as H nu minus H nu naught. This is also one equation which will correlate stopping potential with the energy. That is how we can correlate. So what is the conclusion? What exactly do we conclude from photoelectric effect? That photoelectric effect is instantaneous. What exactly is the effect? Effect is instantaneous. The photoelectric effect is instantaneous. What is the meaning? It means that if light of characteristic frequency, what is the meaning of frequency? Characteristic frequency, frequency should be greater than the threshold frequency. If light of characteristic frequency is incident on a metal surface, then there is no time delay in emission of electrons. It occurs instantly. This is what is called the effect is instantaneous. What about intensity effect? What is effect of intensity? Effect of intensity, if you want to understand, then it is this way. If light of frequency less than threshold frequency is incident on a metal surface, even if we increase the intensity to extremely high, it is not able to give any photo emission. Why? Because see, every photon will supply energy which is less than the work function for the metal. Then how can there be emission of electron? Emission of electron happens only when energy greater than the work function is incident. Therefore, even if you increase the intensity increase means what? Number of photons you are increasing per unit area, right? That is what is intensity. But then if the frequency is not greater than the threshold frequency, it is not going to matter anyway. But take the other case. If the frequency is greater than the threshold frequency, and if I increase the intensity, definitely more number of electrons, photoelectrons will be emitted. The strength of current increases. So if the incident frequency is greater than the threshold frequency, intensity increase will bring about increase in the photo current. This is what is the effect of intensity. And what about effect of frequency? Well, effect of frequency is very simple, because effect of frequency, just now we have seen, unless until the frequency of the incident radiation is greater than the threshold frequency, photo emission can never occur. That is the effect of intensity. Compulsorily for photo emission, frequency of the incident radiation should be greater than the threshold frequency. Then only photo emission can occur. That is exactly how we can summarize photoelectric effect, and we can justify that photoelectric effect is confirmatory proof for the particle nature of radiation. Well students, now what is the relation between the particle nature and the wave nature? So we have to establish the relationship between the particle nature and wave nature. That is given by de Broglie's hypothesis. What it is, let us try to understand. From Einstein's equation, we can say energy is equal to m into c square. This is how we get the energy mass relationship by using Einstein's equation. Now if I use, this is particle nature, if I use wave nature, then from the Planck's theory, what we get, E is equal to hc by lambda. This is what we get. So what we can say, this is one equation for the particle nature, this is another equation for the wave nature. That we can say from the value of lambda. Lambda is wavelength. Wavelength exists only for the wave. Now these two are the same energy. It is the energy possessed by the radiation when in particle form, energy possessed by the radiation when in the wave form. So therefore what we can say is m into c square is equal to hc by lambda. So therefore we can say m into c is equal to h upon lambda. What is m into c? It is nothing but momentum. Momentum is equal to h upon lambda. This is what we have. So this equation where we have P is momentum is equal to h upon lambda. This is the relationship between P is particle nature, because particles only have, and wavelength, this is wave nature. See, we can correlate particle nature and wave. Remember, this equation is applicable only for subatomic particles. This is applicable only to microscopic particle. Never try to apply this equation for macroscopic particle. Of course, you can theoretically apply, but practically it is of no use. How? I will tell you. Suppose that a person of mass 100 kg is traveling with 100 meter per second. So momentum will be how much? 10 power 4. So wavelength will be how much? 6.67 into 10 raised to minus 34 upon 10 power 4. So it is 10 power minus 38. Now just imagine a wavelength of 10 power minus 38. Can we detect it? Theoretically we are getting a value, but practically does it have any relevance? That is why we say that this particular equation is not applicable to macroscopic particle. This is only applicable to microscopic particle. In that case it will have considerable value. This is exactly what we see, relationship between particle nature and wave nature.